Okay, 3.1. Okay, new hypothesis and alternative hypothesis, you should be fine. Computer t-stat, which is equal to b1 hat 5.3325 minus the hypothesized b1 value, which is 4, divided by standard error of b1 hat 0.9884. So your computer t-stat is 1.3481. Critical t-stats, alpha 10%, degrees of freedom 30, one-sided. 10%, one-sided. Degrees of freedom 30, so your critical t-stat is 1.310. Okay, yeah. And then since the computer's t-stat is greater than the critical t-stat, we reject the new hypothesis. One-sided right-tail test, keep in mind. Therefore, the alternative hypothesis would happen. Meaning if x1 study hour increases by 1 unit or 1 hour, then the ceteris paribus condition. Providing there's no change in party hours, then on average, final mark would increase in PRF, and such an increase is greater than 4 marks. Okay, then we can do the next one. 3.2, same parameter of interest, but now the hypothesized value is 5. So can I, this time I don't want to talk. Can you look at the answers? Let me pause for 1 minute to see if you can understand the written explanation. And keep in mind, I changed the alpha this time. Okay, computer t-stat, you should be fine. Critical t-stat, remember I changed the alpha to 1%. Degrees of freedom is 30, so 2.457. Okay. Yeah, clearly computer t-stat is smaller than the critical t-stat, therefore the null hypothesis is not rejected. Meaning from a statistical point of view, the null hypothesis would happen. Meaning if study hour increases by 1 unit or 1 hour, providing there's no change in party hours on average, final mark would increase in the PRF, and such an increase is equal to 5 units. Okay. I hope you are happy with this one. So we have done 2 questions on one-sided right-tail test. So can we do 3.3 and 3.4? Now the focus is on the next slope parameter, B2. It is negative, and then I want to know in the true PRF, is it equal to or less than? You spot the keyword less than or smaller than, that it implies one-sided left-tail test. We usually do one-sided left-tail test when the slope parameter is negative. Okay, alpha is 5%, 5%. Degrees of freedom 30, so 1.697, but we have to add the negative sign. But let's go back to the full answers. First step, you should be fine. Second step, you just have to be careful with the substitution. B2 hat, which is minus 2.0041, minus the hypothesized B2 value, so minus 1 bracket, divided by standard error of B2 hat. Then you have minus 1.8008 as your computer t-stat. Critical t-stat, as explained earlier, minus 1.697. And then this is the graphical sketch. Remember, this is one-sided left-tail test. Therefore, since the computer t-stat is smaller than the critical t-stat, null hypothesis is rejected, meaning alternative hypothesis would happen. Meaning, that is, if party hour increases by 1 unit, providing there's no change in study hours on average, marks would increase in PRF, and such an increase is greater than 1 mark in absolute terms, okay? So smaller than minus 1, but after taking absolute terms, it actually means greater than 1 unit in absolute terms. So keep that in mind. Okay. Okay, happy with this? Then the last one. Again, this time I don't want to talk too much. I want to give you 1 minute to go through the answers. Oops, sorry. This time we do not reject the null hypothesis. Okay, Computed t-stat is greater than critical t-stat, so we do not reject the null hypothesis. So meaning from a statistical point of view, the null hypothesis is more likely to happen. Meaning, if party hour increases by 1 unit or 1 hour, providing there's no change in study hours on average, final mark would decrease in the PRF, and such a decrease equals to 2 marks. Okay? Okay. Oh, why do I close the file? Sorry. Okay. We actually need this study guide. Sorry. Why did I close the file? Okay. So, okay, what's going on here? Okay. Confidence interval. This is the formula. So you see the plus or minus sign because of the upper limit and lower limit. It is equal to the sample regression parameter plus or minus the t-stat, which you have to find from the t-table. Okay, remember it is just like the two-sided hypothesis testing. We have to split the alpha into two parts when we look for the t-stats, and then your t-stat multiplied by standard error of the relevant parameter. So let's look at question 1. Okay, sample size is 20, k is 2, degrees of freedom is 17. Again, it is still that marks example, but I changed the parameters and standard error of the parameters. So 1.1, confidence interval of the constant. Okay, so in other words, you have to substitute B0 hat here, standard error of B0 hat, and then the t statistics, 99% confidence interval, meaning alpha is 1%. Degrees of freedom is 17. So remember, top row gives you half of the alpha, half a percent. Second row, your full alpha, 1%. 17 degrees of freedom, so your t statistic is 2.898. Okay? Yeah, 2.898, and then you find out this confidence interval of the true constant in the PRF. So it means if 100 samples of size 20 are selected and 100 confidence interval are constructed, 99 of them would contain the true B0. And then focusing on the above confidence interval, which is just one out of the 100 confidence intervals that we have done. If all the excess study hour is 0 and party hour is 0, on average, final mark is lying somewhere between 30 and 80 in the PRF. Okay, next one has to do with the confidence interval of the true B1. Okay, so it is the confidence interval equals to B1 hat, 6 point something, minus standard error of B1 hat, 1.5 something, and then the t-stats. Remember, I changed the alpha to 5%. So top row, half of the alpha. Second row, full alpha. Degrees of freedom, 17, so 2.110 is your t-stat. Then this is your range. Positive, so it conforms with theory, okay, because it relates to study hours. So confidence interval, if 100 samples of size 20 are selected and 100 confidence intervals are constructed, 95 of them would contain the true B1. And then for the above confidence interval, it means when X1 study hour increases by 1 unit, providing there is no change in party hours, then on average, final mark would increase by somewhere between 2.7 something and 9.45 something units in the PRF. Okay. And then 1.3 is on the other parameter, B3, but B2, sorry, but it's negative, so you have to be careful with the substitution. And I changed the alpha to 10%. So confidence interval equation, B2 hat here, standard error of B2 hat, and then the t-stats, 10%, second row, my full alpha, top row, half of the alpha, 5%, degrees of freedom, 17. So you have 1.740. Okay, negative range, so it conforms with theories. So interpretation, if 100 samples of 20 are selected and 100 confidence intervals are constructed, 90 of them contain the true B2. Focusing on the above confidence interval, it means when my X2 party hours increase by 1 unit or 1 hour, and then ceteris paribus condition, providing there's no change in my X1 study hours, then on average, expected final mark, why do the text, are the text missing? Expected final mark would, let me just copy this. Apologies. Final mark will decrease by somewhere between 0.53569 and 5.6513 marks in the PRF. Apologies, and I also have to amend the study guide actually. Okay. So I hope you are happy with what we have done so far, and then we can move on to now this time, the previous hypothesis testing, the t-test we have done, only test on one parameter at a time. But now what if we want to test on two parameters at the same time, and we want to focus on whether the two PRF parameters are equal, okay? At third year level, we conduct this t-test on equality of two parameters only as two-sided test, but now at honors level, bootcamp, we take it one step further. We can do it either as one-sided or two-sided test. And assuming the test is about equality of B1 and B2, degrees of freedom is still the same as the usual t-test on one parameter, n minus k minus 1. Okay? And then the computer t-stat is this equation. If we focus on B1 and B2, then this is the equation. So numerator, B1 hat minus B2 hat, denominator, square root. And then variance of B1 hat is actually the square of the standard error of B1 hat, plus variance of B2 hat is actually the square of the standard error of B2 hat, minus 2 times covariance between the two sample regression parameters. I must give you information on the covariance. And then similarly, if the question is about equality of B2, let's say B2 and B3, you just have to change the equation. So that would become B2, B3, and then B2, B3. So read the question carefully. So let's do question 6. This is the sample regression function. Currently, you see that B2 had 1.8 something and B3 had the male dummy. They are quite close to each other. So I want to know what's happening in the PRF. Would these two parameters be equal or not? You spot the keyword or not, then it means two-sided test. Alpha is 1%. Okay. Step 1, you should be fine. New hypothesis B2 equals B3, alternative hypothesis B2 not equal to B3, so two-sided test. Computer t-stat, numerator B2 hat 1.8745 minus B3 hat 1.2732, denominator square root. Variance of B2 hat is actually the square of the standard error of B2 hat. This is why we take the square of 1.7334 plus variance of B3 hat, which is actually the square of the standard error of B3 hat. This is why you see plus 0.4444 square minus 2 times the covariance between B2 hat and B3 hat. As I said before, I must give you information on covariance. So 0.1234. Then you do all the calculations in the denominator, then you take square root. And then your answer is 0.3498. Critical, sorry about the spelling error there. Critical t-stats. Okay. Degrees of freedom is actually 120 because 124 minus 3 minus 1, 120. 120 and then alpha is 1%, so it is here two-sided 120, so plus or minus 2.617. Okay, yes. And then since the computer t-stat lies between the two critical t-stats, new hypothesis is not rejected, meaning from a statistical point of view, the new hypothesis would be more likely to happen, meaning in the PRF, the true B2 would most likely equal the true B3. The meaning tutorial attendance and the male gender dummy would have more or less the same impact on academic performance in the PRF. So in the next video, we will do the next question on the t-test on equality of two parameters.